All right, welcome back, everybody. Hope you had a good weekend. Today we're going to be continuing with function notation. So our agenda for today, if you haven't already completed it, make sure that you complete that due now. It should be those two questions. Our video lesson, and then after our video lesson, there'll be a check for understanding, so there'll be a review quizzes for this one. And again, make sure that you watch the entire video. I will be giving the password for my check to see if you watched it. So make sure that you do that because that is for a grade. All right, so let's take a look at function notation. All right, so equations can be written in a form called function notation. We use this as a quick way to evaluate functions for a given input. All right, so here's our example, y equals 2x minus 8. So we could look at this as f of x, right? We just kind of substitute that y equals 2x minus 8. Because remember, our y value is considered our output, and our x value is considered our input most of the time. So this reads f of x equals 2x minus 8. So let's see some practical examples for this stuff. All right, so give f of x equals x plus 7. So for these ones, when we're giving a value, we're substituting this in whenever we see an x. All right, because this is our f of x. So this will look like 5 plus 7. All right, so then we evaluate. So positive 5 plus 7, that's going to give us 12. All right, and we can do that the same thing for both b and c. So this is negative 1 plus 7. This will be negative 3 plus 7. All right, so negative 1 plus 7 is going to be equal to positive 6. Negative 3 plus 7 is going to be equal to positive 4. All right, so we're just substituting that value whenever we see x, because that's what we're looking at. All right, so now we have g of x. So this part doesn't really matter. It could be f, it could be g, it could be any letter. Whenever you have it, something like this, it means it's in function notation, right? So 3x minus 8, so g, so we do still 3 times, we substitute that for our x, minus 8. All right, so 3 times 1, we get 3. It's in 3 minus 8, we get negative 5. All right, so we can plug those in for each of the other ones. And give a little bit of space in there too. All right, so 3 times negative 3, we get negative 9. Negative 9 minus 8, we're going to go farther into our negatives, and we're going to get negative 17. All right, 3 times 0 is 0 minus 8, we get negative 8. All right, not too bad. Let's try a couple more. So now we have our function squared, and we have more than one instance of our variable. It's fine. We just substitute it wherever we see that variable. So this will look like negative 4 squared minus negative 4. I'm putting those into parentheses so we can see where our substitution is taking place. All right. So negative 4 squared, it's like negative 4 times negative 4. That's going to give us positive 16. All right, positive 16 minus negative 4. We can think of that as keep change if we wanted to. So we can add 4. All right, and then that was going to give us positive 20. All right, so I'll plug these in for the next ones. Give it a little bit of space. All right, so negative 1 squared is just going to give us positive 1. Minus negative 1 is the same thing as adding 1, so we get positive 2. All right, 7 squared, we're going to get 49. 49 minus 7, we're going to get 42. All right. There it is. Okay, we'll change colors. All right, so now we still plug these in like normal. So 3 times, all right, negative 4 is going to go where that x is. All right, so what's this going to look like? First, we got to square this first. So it's going to be like 3 times negative 4 squared. It's going to be positive 16 plus 7. All right, I'm going to do a little arrow, weird squiggle arrow. So 3 times 16, what do we get? 3 times 16. We get, what, 48 plus 7. All right, and then we just evaluate this. Whoop. There we go. So 48 plus 7, we get, what, 55? All right, and we just do the same thing for the other ones. So this would be 3 times negative 2 squared plus 7. And this, I'm just going to give myself a bunch of space for this one. All right, so 3 times negative 2, or first they're negative 2 squared, so we get positive 4. So it's like 3 times 4 plus 7. So I'll do another squiggle. So we get 12 plus 7, and so we get 19. 3 times 0, right? So we get 0. 0 times 0 is still 0. So 3 times 0 is 0. 0 plus 7, we get 7. All right. Okay, so we got a little bit more complicated, but we still follow those same principles, right? So let's take a look at our first one. So we get 2 times negative 8 squared plus 4 times negative 8 minus 9. All right, looks complicated. It's not too bad. All right, so negative 8 times negative 8, so we get 2 times, what, 64? Plus 4 times negative 8, we get, what, negative 32? Minus 9. All right, so 2 times 64, we get 128. Just going to do a little area over here. 128 minus 32, because when we're adding a negative number, it's the same thing as that. So minus 9. Let's just do this in our handy-dandy calculator real quick. 128 minus 32 minus 9. We're going to get 87 for our solution. All right, let's try 2 more of these. All right, so I'm just going to do the next one, and then I'll do the last. So 2 times, actually, it'd be a good idea to do this in a different color, because there's a bunch more steps with this one. So 2 times negative 5 squared plus 4 times negative 5. Just plug in that wherever I see our x. Minus 9, right? So negative 5 squared. Ooh, hello. Come on. That was weird. Weird. All right, so negative 5 times negative 5, we get positive, what, 25? So 2 times 25 plus 4 times negative 5, we get negative 20 minus 9. All right, so do our little arrow. 2 times 25, we get 50. Negative 20, so we do minus 20 minus 9. I don't know why it's doing so many little dot things. It's a little weird. So 50 minus 20, we get 30. 30 minus 9, we get 21. All right, one last color for this. Oh, for the password for this one, our password's going to be magic. Our password for the video is magic. All right, so we're going to plug in negative 2. So 2 times negative 2 minus 4 times negative 2. Hopefully we don't get as many dots. All right, so negative 2 times negative 2, we get 2 times 4 minus, okay, 4, or negative 4 times negative 2. Oh, sorry, 4 times negative 2, we get, what, negative 8? Minus 9. All right, little arrow. 2 times 4 is 8. Whenever we're subtracting a negative number, we can keep change, so it's like we're adding 8 and then minus 9. So we have 16 minus 9. All right. So we get, what, 7? There we go. All right. Remember, the password for today is magic. All right. So let's say we're given a graph, right? This makes the process so much easier with this, right? So this is f of negative 4. Think of that as our x, right? So we're going to find, all right, when x is negative 4, where is our y value? So we go 1, 2, 3, 4, and then we find it right here, right? So our y value is going to be positive 2, all right? What about f of 0? All right, 0, we get 0. Pretty quick, right? What about f of 2? We have negative 2. F of 5. So 5, we get negative 1. Super quick when we're given a graph, all right? So for your task, I would like you to do this short quizzes for our review. It's reviewing our function notation. We're going to have a mixture of graphs and a mixture of equations to evaluate. All right? If you need any help, please let me know. Thanks, guys.